Hello everyone. Um, Today we'll talk about ROS Development Studio. To start with, ROS is the robot operating system. It is a um, what do you say? It is a software development environment for robots. Probably development environment is not proper. It is better to call it is a software package itself. And it is called operating system. That means robot operating system. That means it has all the components of the operating system in the sense of lower level drivers and things like that. So maybe in a different tutorial we'll talk about ROS. Today we are going to talk about ROS Development Studio. uh, so ROS Development Studio is a cloud facility that provides you an environment with Linux, ROS and other softwares pre-installed. So it's a platform independent environment, so you just need a browser. It does not matter if you are on Windows, Linux or Mac. You should be able to make use of the ROS platform and the power of Linux without having to go through the installation process. um, Ideally I will recommend installing Linux and then installing ROS on your system. This will give you the power, performance, speed. Those things will be available to you. But if in case you cannot do it, then ROS Development Studio is the answer. So if you search ROS Development Studio on Google, most likely the first or second link will take you to the website. So let's do that. So here click on the ROS Development Studio. So there was a login button. So if you click on login button, it will tell you to log in using your Google ID or Facebook ID. You can use one of them to log into this one, and then probably you can go to the ROS Development Studio. So for me it is already stored, that's why it can identify me by my name. So I'm able to log in. So what you can see is that on the left hand side you have um, these tools, and it shows you that you have a basic access to 2 CPU, 0 GPU and 8 GPU of RAM. So they allow you to work probably 8 hours per day, not more than that, and moreover you don't have access to GPU. So the good thing is it's free. So we will for today's tutorial we'll see how we can use ROS Development Studio for learning some of the ROS basics of ROS programming. So what we'll do is that we'll create a ROS file by clicking on this button, and we say beginners ROS tutorial, and it uses Ubuntu 16.04, ROS Kinetic and Gazebo 7. You can choose 18.04 ROS Melodic as well, but we'll use ROS Kinetic and 16.04 because Kinetic is more supported. It has more number of packages compared to Melodic, so we'll use that. We are not using a robot right now, and we'll make it public. It's up to you, but we'll just create one environment. You see, it creates a ROSJet module. So we'll use the basic one. If you pay the money, probably you can use the professional version that has GPUs and a higher RAM. So let's open now this one. So while it is opening, what we will do is that we will go through the some basic ROS tutorial here, just to understand how the ROS is organized, robot operating system is organized. The details are already there on this particular link, wiki.ros.org, and you can go through the tutorials. And these are beginner level tutorials, these are intermediate level, so we'll go through the beginner level tutorial first. So today in this particular tutorial we'll try to cover pretty much the first 5 tutorials till understanding nodes. Maybe 6 we'll see. These 6 things we'll try to cover. So let's see if our environment is ready. Yes, it is setting up our environment. So as you can see, it is creating instance of Ubuntu 16.04, ROS Kinetic and Gazebo 7. My network is slow, so you'll have to bear with me. Yeah. So while it is installing, if you're installing on your system, then we can check if these things are there. For example, print environment will tell you what ROS variables are there. Particularly, you can check the environment variables like ROS root, ROS package path, etc. Then we'll create a catkin workspace environment. This is where we build ROS packages. So any program that you develop and compile, it is done using catkin make. Earlier people used ROS build, but now we'll use catkin one, which is common with ROS. Let's hope that our system is installed. Yes, so our ROS Development Studio is ready for use. It is this is a Jupyter notebook. You can write documentation and you can run Python programs here directly. So it has all the facilities of a Jupyter notebook. So you can search Google on Jupyter notebook and you can see what you can do. Basically it's a browser based editor for Python, where you can include documentation as well as the program itself. So for the time being we don't use it. So what we'll do is that on this left hand side you click on tools and you click on shell. Okay. Well, we believe that the ROS is already installed. So to check that, we'll see echo. What we'll do is we'll separate this window. Yeah. So we'll first check print environment grep ROS. So so you can see that there is a lot of ROS related variables are there. ROS root, so ROS root shows opt ROS kinetic share.ROS. ROS package path already includes catkin workspace src, which is in the home, and ROS master URI, ROS version, Python version, everything is mentioned. That means ROS is installed here. And if we see ls, so you can see that catkin underscore workspace is already created. So let's go to the catkin workspace, this one. Generally if you are creating yourself, then you'll have to run catkin make here and that will create. So already it is already created here. So we don't have to do this. Let's see if nanocat dot bash rc. Okay. Usually what they say recommend is that you should source uh, this thing, that means source / opt ROS kinetic setup dot bash. Okay, and if you have built the that means if you have run the catkin make inside an empty folder, then it will create these two folders, and you should source devel setup.bash. So what it will do is that the packages that are built within this workspace, they are included to the ROS tree, so we will be able to find these packages from anywhere using the ROS related commands. So we'll cover that later on. So yeah, so everything looks good for the time being. So let's see. So the first step in this tutorial is about creating the ROS workspace. So maybe we can do that, do one thing. We'll probably remove rm-rf catkin RSS. So we'll start from the scratch, so there is no catkin environment. So now we want to do the first step with the ROS is that you create a workspace for compiling ROS packages. So what we do, we'll create a folder called catkin workspace. So cd catkin workspace. Now we just run catkin make. So it says that you need to have a src folder, so we say mkdir src. Now you run catkin make. So within the catkin make, you will have to create a folder called src, and then for the time being you note that everything is empty, there's nothing is there. So we created a catkin underscore make folder, and inside that we created a folder called src, and then we run this one. So then build and develop, this is created when we run the catkin make. Now you should source devel.setup.bash. So what it does is that it updates the ROS tree. So if you see echo ROS package path, you can see that home user catkin ws and src folder is already included into the ROS path. So the this is the main ROS path, and with that this is included, that catkin ws and src. So any package that is built that is kept within the src folder and built will be found by the ROS commands. Okay, so we finished this part of how to create a ROS workspace. So we did this. So every time you build a new package, you should source the devel setup.bash file to update the ROS tree. Okay, so and we have done this ROS package path. Okay, so this step we finish. Alright, so we finished the first tutorial. Now the second tutorial is about navigating the ROS file system. So that means we'll learn about finding the packages to understand how the ROS files and packages are organized. So for this part we need to have this ROS tutorial package. Let's see if we can install this. So it says sudo apt-get install. I believe that is already installed, but just for the sake of checking, rex kinetic ROS tutorial. Yeah, so it says it's already installed. I expected that because it already has everything inside it. So that is done. So the first file system tool that we'll use here is called ROS Back Find. That means this is used to find package ROS Back Find ROS CPP. If something is installed, it will show you. For example, ROS CPP is installed at this location. So this is a useful command to find ROS packages. For example, if I want to search ROS Back Find Turtlebot, Turtle Seam, let's say. Yes, it says it's there. And if say ROS Back Find Beginners Tutorial, let's say, it says that it is not found. So ROS Back Find is a useful tool to see if a particular package is installed or not. Another is a ROS CD. If something is installed, then you can use ROS CD to directly go into that folder. For example, if I say ROS CD ROS CPP, you see you are directly going from your catkin workspace and folder directly into the ROS CPP folder, and you can then access all the files. You can see the package file and things like that. So one thing I like to point out is that when you are inside the workspace, src, okay, we will save it for later time, this is not the right time. So ROS CD is a command that you can use to jump into a particular package. Okay, ROS, for example, if I want ROS CD turtle seam, so you can directly go into that folder turtle seam now, and here you can go through all the folders, packages, files. So it's very easy to navigate using ROS CD once the package is installed. All right, so okay, if we do ROS CD log, there is nothing called ROS CD log, I don't know. So what you do is that we'll go back to CD catkin workspace, and if we see ROS CD log, so is that there is no such file. So it says that if you have not run any ROS programs yet, then it will give one error saying that doesn't exist. So that means we haven't run any program yet. So let's not worry about ROS CD log for the time being. Let's see the ROS ls. So it is another command. It is similar to ls command in Linux. So instead of going to that particular folder, it will show you the content of that folder. For instance, if I say ROS ls ROS CPP, it shows me the content of that folder, but its current directory doesn't change. That means pwd doesn't change. That the pw is a command for present working directory. This doesn't change. But if I do ROS cdd ROS CPP, you see the pwd thing changes. That means now my present working directory is this one. All right, so so ROS ls is a good command to see a content of a package. For example, if I want to see turtle seam, and remember that when you type, you can use tab for auto completion. If something is package is already there in the ROS, you should be able to find it using tab command. This is very helpful, particularly when you will have to type very long commands. Okay, so ROS ls, you see, if you do, what you can see is that you can see the content of that folder. All right, we finished this ROS ls. We talked about tab completion. So if something is installed in the ROS, if you press tab, it should show you the hints and it will auto complete it. So for example, if you see if you do ROS CD turtle, and then you put tabs, it says turtle, and if you tab more it shows you all the packages that is starts with turtle, you know. So maybe I'll go to turtle scene and so on. So tag completion we saw, and so as a review, in this tutorial we saw three main commands. One is a ROS Back, this is to find packages which are already installed in ROS CD to jump into that folder, and ROS ls just to see the content of that folder without jumping. So this is, we have done the second tutorial. Now let's go to the third tutorial, which is about creating a ROS package. So we'll build a ROS package here. Alright, so we'll be building the package using catkin. We are not going to cover the ROS build, which is an older system, so we'll talk about catkin packages only. This is called catkin package. So any catkin package will have these two files. One is a CMake list file, another is a package.xml file, and you know, and the organization in the catkin workspace, you will see that this is the main workspace folder that we call catkin workspace, and there will be src folder. In src folder there will be a CMake list file, and then there will be multiple packages, package 1, package 2, and so on, and each one of them will have a CMake list file and package.xml file. That means every package that you create within the src environment must have these two files. Okay, so this organization is important for catkin workspace to work properly. So to show how to create a catkin package, so we'll first go to we'll go back to our catkin workspace. So this is our main catkin workspace environment where we'll create packages. So we'll go to src. So the and you see inside src there is only one file called CMake list file. Okay, this is created when we run catkin make for the first time. So now what we'll do is that we'll create a new package called beginners tutorials. Okay, so in order to create a catkin package, we use the command catkin catkin create package, create package, then beginner tutorial. We'll just stick to the name so that you know it avoids confusion, and then we type the other packages that this beginner tutorial will depend upon. So standard messages is 1, ROS Py, and ROS CPP. That means we are saying that create a catkin package named beginner tutorials that depends on other packages such as standard messages, ROS Py, and ROS CPP. So if you do that, it says it has successfully created the package. Let's see how it looks like. See, it creates a folder beginners tutorial. Let's go to the beginners tutorial, and if you see here, you have these two files, CMake list file, package.xml file. It has an include folder and src folder, and all of them are empty, but main thing is that these two files are there. For example, if you go to include, it has a beginners tutorials. It is not important, nothing is there. Basically it's an empty folder anyway. So if you go to src, again it is an empty folder. So the important thing is that when you run the catkin create package, it creates this CMake list and package.xml. Okay, so we talked about this one. You've mentioned the package name with catkin create package, then you can mention the other dependencies like depend1, depend2, depend3, Now we'll build this. Even though it is empty, we can still build our package. So we go back to the main catkin workspace environment and run catkin make. Why it is giving me the error? CD SRC, we didn't choose anything. Beginners tutorials, we didn't do anything. Source devel setup dot bash, let's see, and catkin make. Oh, maybe the standard messages was wrong. It was okay, I missed an S. Fine. So what we'll do, we'll redo the thing. RM minus RF beginner tutorials. So we'll catkin create package beginner tutorials standard messages MSGS ROS by ROS CPP. Okay, so let's see now if we can run catkin make. Yes, now it says that it is able to create the beginners tutorials is there. So the earlier error was that I missed an S with the standard messages, so I missed an S there, so you have to be careful about the spelling here. So you are able to build it now. Even though it is empty, we have built it. Now the moment you have built it successfully, you don't forget to source the setup.bash file, so that you know the tree is updated. Now if I type ROS cd beginners tutorial and press tab, beginner source devel setup.bash ROS cd. Why the ROS cd is not working? Beginner tutorial. Yeah, it is working, but why the tab is not working? Let's see. ROS cd. Now it is working. I don't know, maybe you know the speed is slow or something is there. So if you what I did is that if you go, you are in the catkin workspace, or for that matter you are anywhere, you know, you are in the home directory, and if you type ROS cd and beginners tutorials you and press a tab, you should be able to find the package. See, directly we are inside the package. So that shows that you know, beginner tutorials have been created properly. Okay, so we'll see you know, package dependencies. So if you see ROS Back cd catkin workspace, now ROS Back depends. Okay, this is the ROS Back depends 1 beginners tutorial. If I type this, so I think we'll have to run the ROS dev update once. Okay, so now see if I can do ROS back depends one beginners tutorials. It shows that that means depends one stands for the first order dependencies. So it says that it depends on ROS CPP, SPI and ROS standard messages. Now if I say ROS back depends beginners tutorials, it shows that it depends on so many other packages. That means there's a second order dependencies. Now these dependencies are specified in the package.xml file. So if we do ROS cd beginners tutorials and then vim package xml, we use the vim editor here, so probably it is easier to see and execute. You can see the first is an XML version 1.2 package format. You give the name. So this is standard things. You need to have the name, description and maintainer email ID, license. This thing something is common, you will find it. And after that, all these options are commented. We will visit them later on. For the time being, you see that it depends on catkin, it depends on ROS CPP, ROS by standard messages, and all this we mentioned. That's why executable as well the build depends on these things. Okay, so we see that if you open it, you can see that these dependencies are there because we specified them on the and you can check the dependencies of other packages. For example, you can ROS back depends one for ROS by itself depends on this one. That is why when you run the ROS back depends, it shows you all other dependencies, because the other dependencies depend on other packages. So that's why when you run the ROS back depends on the beginner tutorial, you see all these dependencies which we didn't mention. These are secondary dependencies. So some are primary or first order dependencies and other are indirect dependencies are there. Okay, so a little bit about the package.xml file. So we talked about this. It will have a standard description, maintainer email and license things. Okay, and then there will be some dependency tags that specifies what packages it will depend on. And as we go along the tutorial, you will see how we modify it for our packages, depending on what kind of packages we're building it. All right, currently it says that it depends on these three main that we mentioned packages. Okay, so finally it looks like this. So we'll also customize the CMake list file later on, so that we'll see. Then after this package is created, then we go through the building the ROS package. That I think we have already done. So the idea is that you just run the catkin workspace catkin make, you do it, and it should build the whole thing. That we have seen already. If your source is located in somewhere else, which is not recommended, so we don't talk about it, but if it is, then you can mention this. So we have already seen that everything is built and we have done this one. So now we go to the next topic, which is ROS nodes. So as always, we'll check if particular package is installed. Sudo apt-get install ROS kinetic, ROS tutorials. So it says that it's installed. We already checked that one. So here we'll talk about some core concepts of ROS. One is a nodes, messages, topics, master, ROS out, and ROS core. So I'll just read out. It is easy to understand. Node is an executable that uses ROS to communicate with other nodes. So it's a you can say that it is an executable program that can communicate with other nodes as well. Okay, and messages are the data type through which the nodes communicate with each other. That means you can subscribe to them or publish using the messages. Okay, so nodes can publish messages to a topic. Okay, and can also subscribe to a topic to receive the messages. So message is the medium, it's kind of a language by which you communicate with the other nodes. The one node communicates with the other node using messages. It's the message that is being sent back and forth. And topics are something that publish these messages, and subscribers can subscribe to these messages. That means subscriber can receive the messages and publisher can publish the message. And this master is kind of a name service for ROS, so it helps nodes find each other. Okay, and ROS out is the ROS equivalent of standard out or standard error. Just like terminal is a standard out in a Linux environment, ROS out is a equivalent of that, standard output or standard error. So, and rawscore is it's a combination of master, ROS out, and parameter server. Okay, this will talk about it. That means it's the master. It maintains all kinds of nodes. It has a standard output, standard error, so you can check the error messages and see the output of various nodes, and find, and plus it has a parameter server. So we'll go through all these things one by one. So we'll get a better understanding of these things. So let's see a nodes first. So what we say, the nodes are nothing but more than an executable file. Let's say it's a program that can execute. So ROS nodes use ROS client library to communicate with other nodes. We'll see that one. So nodes can publish to a topic. It can subscribe to a topic. Okay, that is how it can communicate. It can communicate by using a service itself. So one node can communicate with another node either by using topics to publish or subscribe messages, or by using a service. There are two ways of communicating with other nodes. Okay, and it uses client libraries, either the ROS.py, that is a Python client library, or ROS CPP. So in this tutorial we'll focus more on the Python client library. ROS CPP you can see yourself. Okay, so the first thing we'll do is a rawscore. Okay, so let's do that. We clear it. Control L clears the screen, and if you type rawscore, so it says the ROS distro is kinetic. ROS version is 1.1214. It has a URI. It has that is the IP address of the master URI. It is used when you have other clients connecting to this one. So for the time being, let's not worry about it. Just to understand that it is the master service that maintains all other nodes and helps them find each other, and you can do it's like a main program. All right. Okay, so it shows something like that. And now let's open another terminal. So click on cell. So all the cells are accessible here. So you drag it to this side so that we can see them together. If I type ROS node list, you can see that it shows only one node, that is called ROS out. Okay. There is only one node called ROS out. So the rawscore only runs one node. This is always running as long as rawscore is running, and it collects and logs nodes debugging output. So we'll see that later on. And if you want to see info, so ROS node info ROS out, so you'll have to give this slash. The slash is the root. So it says that it's a node ROS out. It publishes to a topic called this. This is a message type. It subscribes to ROS out. That means it can receive message at this one, and it also runs two services, get loggers and set loggers, and it has a PID, and you see it is connecting to this. Is a different port is there. This is not master port. Anyway, it runs a different services at a different port. Fine. Okay. Now now the ROS creation will run some more nodes. This is nothing more you can do. It has only one node, and we don't know what it does. So let's do something more exciting. So it says that we'll run ROS run. So at least we saw a command called ROS node. Next command is ROS run turtle sim and turtle sim. Okay. So it does something, but we don't know what it does. So what we will do is that we will choose from the tools. We'll choose the graphical tools. It's the desktop environment. So if there's a command that starts something graphical, then we need this. So what we'll do, we'll just run it again. Control C, run the same command again. So you see that you can see a graphical window with a turtle in the middle, isn't it? So if I click on this, can you zoom out? Anyway, we'll leave it for the time being. So you can see something like a turtle window. Okay, and now let's start another shell. And say ROS node list. You see now there are two nodes are there. ROS out was already there, and since we started turtle sim, it is another independent program that we are able to see. The independent node now. It is also possible, you to run the turtle sim with a name, turtle sim node. Yeah, it says the turtle sim node. Okay, fine. The name. So if I do it, so let's do that with a new name. So I close it. ROS run turtle sim node. Oh, sorry, I wanted to give some name. so you can give name my turtle. So if you do that, okay, so access the, so if I run ROS not list now, it shows my turtle is there. Turtle sim is all there, the old one, it's still there, it should not be there, but anyway, we'll see that. But at least it creates a new node called my turtle. Okay, so it is possible to ping this new one. So because you see every node is an independent server kind of thing, it has an IP address kind of thing and a port number, so you should be able to ping it. So if I do ping ROS node ping my turtle, so you are able to get a response. You see it has a port 35037 and okay, fine. So all right, I'll control C, I'll do this. Okay, but if I do ROS run ping turtle sim, oh sorry, a ROS node ping turtle sim, see it says connection refused. That means even though ROS node list shows turtle sim, it is no longer active. That means it is turned off, whereas the other one is available at this different port. All right, so to summarize what we did in this tutorial is that we understood what is a rawscore. Rawscore is is the master. It provides the name services for the ROS. It has standard output for ROS, and then it maintains a parameter server. Okay, then we saw some of the commands with the ROS node. Okay, it's a tool to get information about a node. So we use ROS node list, ROS node ping, these two commands we saw. And then we saw ROS run, which is used to run a node for a given package. So we'll stop our tutorial here for the time being. Maybe this part is becoming longer, so we'll continue from the next tutorial next time. Okay, thank you very much.